Hello, I'm Mrs. S from Steps to Success Maths. In this video, we're working through GCSE Higher exam questions on writing recurring decimals as fractions. We're going to start with the easiest and work through to the hardest. Pause the video, have a go, and we'll go through it together step by step. Prove that the recurring decimal 0.7 can be written as 7/9. Okay, so first of all, 0.7 recurring really means 0.7777 and going on forever. Now what we want to do is call this x. Then we want to make it 10 times bigger, so 10x. So we get 7.777 and it keeps going on forever. And the point of doing that is that when we take these away from each other, we're going to get rid of all these numbers after the decimal point. So 10x take away x is 9x, and 7.777 take away 0.7777 is just 7. So we've got 9x equals 7. And then if we just rearrange that to get x on its own, we've got x is 7/9, which is what we were trying to prove. Prove that the recurring decimal 0.39 recurring can be written as 13/33. So again, pretend you don't know the answer and just work from the decimal. So it's 0.39393939. Call that x. Now, we want to make a whole number and we want it to be with the 39-bit recurring. So this time, instead of timesing by 10, because that would only give us 3.93, we're going to times by 100. So that's 39.393939, and that's 100x. We always times them by multiples of 10, never anything else. So if we do 100x and then we take away x, you can see that all these numbers after the decimal point disappear. We've got 99x is equal to 39. So x is 39/99. And then if we simplify that by finding a number that goes into 39 and 99, which is 3, we'll get 13/33. Which is what we were trying to show. Show that 0.57 recurring is equal to 26/45. Now this time it's 0.577777. It's only the 7 part that's recurring because the dot is only over the 7. So it's hard with this 5 here. So if we multiply by 10, we can say that 10x is 5.7777. Remember, the decimal you start with is just the x. Now we're going to work with this one. So if we multiply this now by the original one by 100, that would be 57.777. It's really important that the numbers after the decimal point are in the same order and match. That way you can take it away. So 100x take away 10x leaves me with 90x, and 57.777 take away 5.777 is 52. So x is equal to 52/90, and that cancels if I divide it by 2 to 26/45. Write 0.23 recurring as a fraction in its simplest form. So x is equal to 0.233333. Let's make it so that the 2 is the whole number. So 10x is 2.33333. And now we like the 0.3 bits at the end. So the next one we can multiply by, so that happens, would be 100x. 23.3333. 100x take away 10x is 23.333 take away 2.333. So that's 90x is equal to 21. So x is 21 over 90, and I can divide that by 3. So that's 7 and 30. 7 over 30. Prove that the recurring decimal 0.126 can be written as 42 over 333. So x is equal to 0.126, and it's all recurring. 126, 126, 126 forever. Now, we want to get it so that the 126 repeats. So we're going to need to multiply this time by 1,000. So 1000x is 126.126.126.126. We got that x is 0.126.126. So if we subtract it, 1000 take away x is 999x, and 126 point all these numbers, take away 0 point all these numbers is 126. So x is 126 over 999. And to simplify that, I'm going to divide it by 3. I can look at the answer I'm aiming for and see it's 333 on the bottom, so I know I'm dividing by 3. And that gives me 42 over 333. Write 2.136 as a fraction in its simplest form. So as a fraction, not as a mixed number. So this is 2.1363636. Always be really careful about which part of your fraction is recurring. Now if I multiplied that by 10, I'd get 21.3636 is 10x. And that's good because the 0.36 is the bit that recurs, and that's on its own after the decimal point. Now I can also multiply by 1000x to get the same idea. So if I multiply by 1000, I've got 2136.363636. So now if I do 1000x subtract 10x, I'm going to get 990x is equal to, everything after the decimal point disappears. So I've got 2136 take away 21, which is 2115. So x is 2115 over 990. And because that ends in a 0 and a 5, I know it divides by 5. So if I divide that by 5, I've got 423 over 198. Write 4.165 recurring as a mixed number. Give your answer in its simplest form. Okay, so a mixed number, so it's going to be 4 and something, and I'm going to take the 4 out to start with, and I'm just going to work with 0.165 recurring as my value of x. So x is equal to 0.165656565. And if I times that by 10, 10x is 1.656565. And the next one, where I just get this repeat of 65 after the decimal point, will be 1000x. So 165.6565. So if I take those away, I've got 1000 take away 10x is 990x. And then 165 point the recurring bit, take away 1 point the recurring bit. So that's 164. X is equal to 164 over 990, and I can see I could divide that by 2, so that'd be 82 over 495. And don't forget the 4 for the whole number part. 4 and 82 over 495. Work out 0.36 recurring divided by 0.93 recurring. So we need to write each one of these as a fraction. Let's start with 0.36. So x is equal to 0.363636. So to get it so that we've got the extra bit recurring, we'll need to multiply by 100x. So 100x is 36.363636. And then if I just take x off that, I've got 99x is equal to 36. So x is 36 over 99. And now if I do my 0.939393, and I'm going to call that one y, and I get 100y, that'll be 93.939393. So 100y take away 1y is 99y, and that's going to equal 93. So I've got 93 over 99. So the calculation I'm going to work out is 36 over 99 divided by 93 over 99. Remember, when you divide, you keep the first fraction, flip the second fraction and change the sign. So 36 divided by 99 times 99 over 93. The 99s will cancel out, leaving 36 over 93. And if I divide that by 3, on the top and the bottom, I've got 12 over 31. This is a really tricky topic, so you're going to need some practice. There's a free worksheet with work solutions linked in the comments. Make sure you subscribe to my channel so you don't miss out on any videos or free worksheets.